Volume, quick one. All you need to know is that you will only be asked in the exam to work out the volumes of cubes and cuboids. Cubes are effectively three-dimensional squares that look like this, and cubes have all their sides the same length. And the cuboid is, think, a three-dimensional rectangle. So you normally look something like this. I know these are not straight lines, but these are sketches. They should be straight lines. That's the cuboid. He's normally a bit longer, and not all its sides are the same length. Okay, so if we take the cube, in fact, no, we go with the cuboid over here. So all you need to know for the volume of something is length times width times height. So we can have the length as 10, width could be 3, and the height could be 2. Let's make them all meters. So volume, length times width times height, which in this case, what did I have for length? It was 10 times 3 times 2. 10 times 3 is 30, times 2 makes it 60, so your volume is 60 meters, but instead of squared, it's 3, because you've got 3 m's in the picture, so you've got to have a little 3 at the top. There. The cube, on the other hand, we only need to know one of the lengths. So let's say it is 2 meters. Because all the sides are the same, you only need one length. So volume equals length times width times height, which equals 2 times 2 times 2, which equals 2 times 2 is 4, times 2 is 8, 8 meters cubed. So that is 2 volume puzzles worked out. This one was the cube, and this is the cuboid. Just trim that up. One final thing to note. Sometimes the examiner is a bit cheeky, and sometimes the examiner will show you something like this. But let's say they give you the length, so let's say 7 centimeters. There you go. But they told you this time, they're not giving you anything else apart from one thing, which is that the area of this face is 20 centimeters squared. And then they'll say to you, well, volume, what is it? Well, a lot of students will be put off by this because they were expecting 3 numbers, length, width, height, and they've only got, well, a length and something that they see as completely useless. Wrong. Let's go back to this cuboid over here. If you listen to the previous video, you know that area equals length times width. Well, hang on a minute. There's an L times W over here, and there's an L times W over there. So we could have said that volume equals area of the front face times, well, the area of the front, well, okay, I'll rephrase that. That is length times height, isn't it? If we're being technical. Which, let's be honest, it's 2 lengths. All an area is 2 lengths times together. normally they're the length and width, but in this case, your length of this face is the 3, and your width of this face is the 2. That's why I've put the H in here. Have we got an L and an H in this formula? Yes, we have. So we could rip these off, L and H, and swap them for the letter A. So volume equals A times the length. Actually, no. Change that. That's a width, isn't it? It is the width of this volume. So therefore, sorry, correction, we could destroy the width and the height and swap them for the letter A. So volume could be A times L, i.e. you could have area of this is 6, 2 times 3, times 10, which equals 60. So if we go back over here, we can say volume equals A times L, 20 times 7, 140 M3. Let me just double check for the right. Whoops, that should be a 3 there. Apologies. That's better. Let me just double check I did everything else. Yeah. So volume equal on this cuboid here. Volume equals A times L, which is 20 times 7, 140 meters cubed. In fact, the full title of this is area of cross section. Is the full title of this, but an examiner will understand. You've done A times L, 20 times 7 equals 140 meters squared. They'll get the picture. And that's all I need to go through. What I'll now do is I'll zoom out. You can see all that we've done. And I will remove this just to avoid any confusion. And that's that.